So I'm really excited to be part of this session, and a big thanks to Ben for being a part of it as well. When FuelCell became a customer, I was really excited because the technology that they've got is quite exciting, very closely linked with sustainability. So it's a really nice example that we can talk about today. But what we're going to talk about, Ben's going to give you an introduction to FuelCell Energy, what the product is, the company, and then some of the challenges faced, so why they looked at aPriori to help with that. Then we'll look at should cost and what we call should carbon, so we'll have a little explanation of that. And then we kind of put together a bit of a case study to look at some of the opportunities identified using aPriori. So with that, I'm going to hand over to Ben to take us through FuelCell Energy. Thanks, Ben.
Thanks. All right. Hi, everyone. As I've said, Ben Aldrich. I've been with FuelCell Energy for about 17 years, and we've been with aPriori for about 4 months now, I think. So it's been pretty exciting. I'm really looking forward to digging into the software and getting a lot out of it. Just real quick, go through sort of what FuelCell Energy is and what we do. We're here to enable a world empowered by clean energy. We have four core values. We really see aPriori fitting in for accountability and innovation, but we also prioritize integrity and safety. One of the things that we do is we decarbonize power. We do this by producing decarbonized power or by capturing carbon to decarbonize other power production. The other thing that we can do with our product is produce hydrogen, both to supply it or to store it for later use in some of our products. Just some quick company highlights. We have over 220 megawatts currently in our field across 95 different platforms. We have a lot of patents for intellectual property for the technology that we have. We're currently at 500 plus employees. We've been around for quite a while, since 1969. And we have locations all across the world, both in Canada. There were some Canadian jokes earlier, so I'll refrain. Connecticut, Germany, and Asia, with South Korea and Japan. Just a real quick background on our history. We have been around for a while. We started out as an energy research company, mainly looking at batteries and fuel cells. As we fast forward into the 2000s, we demonstrated our first distributed hydrogen plant, which is important because we just recently demonstrated our first commercial product, which is in the 2023 bubble there. We've also, last year, we introduced our solid oxide electrolyzer and fuel cell products. So that goes back to the storage and reuse of hydrogen as a way to store energy and then utilize that energy later through a solid oxide fuel cell. This is our leadership team. We've had people here who have been with the company since almost its inception to a few months. This is actually the important one that I wanted to get to, the ESG strategy. We've been talking about that a lot, and it directly relates to the CO2 and carbon. And this is very new to FuelCell. We just recently added a group that's responsible for this. It was very timely that we had launched aPriori, because it was probably about a month ago. I got asked some questions about, like, hey, can we figure out how much carbon is in our product? And I was like, I think I can. So it was very good timing. So I really look forward to leveraging that portion of aPriori to help our ESG team in producing some of these numbers and analysis of our product. All right, and actually this was mentioned earlier as well with similar numbers, but electricity is going to be big in the future, and as a company that produces a product that generates clean electricity, that's going to be big for us. So I'm really looking forward to the bright future that energy has. Let's see. Yeah, I talked about this, decarbonizing power and producing hydrogen. And then, so just a real brief overview of sort of our different product platforms. We have our solid oxide fuel cells and electrolyzers for producing and storing hydrogen. Our carbonate platform, which is the one that I'm mainly working on, is capable of capture, trigen, as well as separation. And both our carbonate and solid oxide products work to decarbonize power. We have a lot of different applications that we can use our product for, both from just generating power, generating hydrogen for transportation. A lot of our products are installed in on-site for heat and power. And we also are able to utilize waste energy to create biogas, which then we can run through our fuel cell and create electricity and heat. And yeah. All right, these are actually links, so if you come up and push your finger on them, you can get them to work. No. So yeah, we're all about producing clean power and decarbonizing power, and we have a couple of products to do that. And then again, hydrogen, supplying and storing that hydrogen for later use. And I think if I click next, will it show all the answers?
Oh, yes, it will, actually.
It will? Oh.
So, yeah, I'll hand you that.
Tag.
Yeah. So on FuelCell Energy's website, they've got a figure on there of almost 15 million megawatt hours that have been generated by FuelCell Energy's plants. So I wanted to ask, and I've got some sustainable notepads with aPriori on to give out. So I went on to Bard, which is the Google version of ChatGPT, and asked what you could do with 15 million megawatt hours. So they've got a big list on the next slide of potential answers. Does anyone want to hazard a guess what you can do with 15 million megawatt hours? Come on, any guess? Miles driven in a Tesla?
Propel yourself to the moon.
Do you know how far that is? Just any answers at all? No such thing as a bad answer.
5,000 flights around the world.
5,000 flights? That's a good answer.
Bitcoin mining.
How many Bitcoin? Come on, we've got to quantify it. We're all about quantifying stuff at aPriori.
Do I get a notepad?
Yeah. Just hazard a guess. How many Bitcoin can you? 15 million megawatt hours.
1 million.
Wow, he's pretty good. So there's the list. So we're in Florida, 1,000 Florida homes for 1 year. And Florida uses more than the average in the US because of all the AC. 3.5 million miles in the Tesla Model Y. I think that'll get you to the moon and back a couple of times. 100 million Tesla Model Ys. 1.5 million Bitcoins. So pretty significant amount. So yeah, I thought that was a really impressive figure, and that was why I really wanted to have Ben tell FuelCell's story. I'm going to hand back to Ben now, because in the news recently was how FuelCell's trigen production system has really made a difference in your partnership with Toyota.
All right. So, so I alluded to this earlier with our trigen product offering that we have. We just recently announced that we finished this product with Toyota. It's currently in the Port of Long Beach in California. We're able to utilize our product to use, I believe, does it say redirected biogas? But we use redirected biogas to generate electricity for Toyota. We also generate hot water that's used to wash new cars as they come off the ships from Toyota. And then finally, we also extract some of that hydrogen that we would normally convert into electrical power. We just keep it as hydrogen, and we pipe that to the adjacent refueling station where they can refuel their FuelCell Mirai cars. So it's pretty exciting. I was involved with with, going to the plant, making sure that the modules are fine, but it's actually interesting. The modules are pretty much our standard technology with just a little bit of a tweak. There's everything else there at for the plant that was new. So that was a pretty cool thing that we had just done. And then there's just some data. So we produce megawatts of 2.3 megawatts of renewable electricity, up to 1,200 kilograms of hydrogen every day, and it also generates 1,400 gallons of water, which in California, Southern California, is a pretty big deal.
So yeah, as Ben mentioned, FuelCell took on aPriori about 4 months ago. Some of the challenges that were identified are kind of listed here. There was no way to predict carbon at the current time, and really you were relying on suppliers for insights around cost. So there's a significant opportunity for carbon reduction to be a competitive advantage and attract additional investment. Streamlining design iterations, as we saw, being able to try out different things, getting that early manufacturing feasibility. Do you want to comment on any of those, Ben?
Yeah, I think so. The issues identified at the detailed design phase. So for us, and it's come up a lot actually in all the sessions that I've been sitting in, that if your engineering team comes up with a design and then hands it to procurement to go out for quote, it's way too late. So for us, being able to identify a lot of those manufacturing issues earlier in the design process is a really big deal for us, because it'll help speed up that design process and ultimately produce better designs. The other factor that we have to consider is that a lot of the engineers in our team are pretty new, so having a tool like aPriori also helps assist in looking at sort of design for manufacturability issues that a new engineer might not necessarily be able to identify. And then the last part there is, the CO2 manufacturing footprint is, like I said, is very timely, because I just started getting asked questions about that. So it'll be nice to have answers.
So from identifying the challenges and then seeing what opportunities can bring, the next logical step is obviously seeing what capabilities you need to realize those opportunities. And these are some of the ones we kind of jointly identified. Were there any that kind of stood out for you?
I think what I'm kind of looking forward to, and we really haven't started exploring a lot yet, is the improved collaboration, especially with our procurement team. It's always been a challenge to get them involved earlier in the process, and with a tool like this, I think it'll definitely help give them something that they can either start looking for suppliers for, or even start going out for bids if they need to. So I'm looking forward to that.
And then we've just got a brief kind of timeline of how you intend to work with aPriori. So obviously onboarded a couple of months ago. The first workshop, that's really where you identified the first potential savings, is that right?
Yeah. Yep. Yeah, it was interesting as we started rolling our designs in and looking at, having a tool where we could look at like casting versus machining or welding, before we would have to make a design, hand it to our procurement team and get a quote. Now we can run the two designs side by side in the software and get results much faster. So yeah, there were a few items like that where we definitely identified some things that we can look at.
Awesome. Thanks, Ben. Sure. So yeah, next up is really just a kind of brief look. I'll give you that. Okay. Thanks. We're not going to make it onto Dancing with the Stars with that kind of choreography. So yeah, obviously aPriori's been known for should cost analysis for a very long time. So taking the material costs and the amount of material, so the rough mass of the material, all of the tooling required, the manufacturing process, assembly process, and the labor rate based on the regional labor rates, to give a should cost, which is not always the same as quoted cost. And we see customers using that a lot to have fact-based negotiations and facilitate a sustainable, financially sustainable relationship with all your suppliers. And so the next logical step was really should carbon, and it's essentially the same process. We've just added on a couple of extra data points, so the local electricity mix and the carbon factor of the material to give us the total manufacturing carbon based on those. So why should carbon is the next question. Well, with aPriori, we have a really in-depth knowledge of the manufacturing process. So we can give really an unparalleled understanding and level of precision when it comes to carbon. A lot of LCA tools just rely on assumptions, averages. They're not looking at specific geometry because they don't read in any 3D CAD or anything like that. So they're usually working on the finished mass. They'll also look at the average power consumption of a machine. So they'll say, okay, our CNC machine uses this much. The average power consumption is around 30%. It's not necessarily related to a specific part, but this shows the power curve for injection molding. And we simulate this and actually use this power time curve to work out the carbon really precisely. So you can see the energy level is really high when it comes to injection. You've got the clamping, but then energy drops right down when the part's cooling. There's still power being used because the machine's still on. It's still heating the granules in the hopper. And then when it comes to ejection, there's another bump of power consumption there. And this is true for all the different sizes of machines. So you're going to really get a much greater understanding of where the carbon is and what level of carbon. And having price or cost and carbon in the same place just gives you that extra layer of fidelity to be able to compare what makes the most sense for your business. And this was covered in the last session, but really there's 4 levers for sustainability when we're looking at embodied carbon, what goes into the product. And the geometry and the shape actually makes a huge difference. And life cycle assessments can't deal with that. They don't have any way of knowing what the shape or geometry of the part is, because all that's fed into an LCA tool is the mass, the amount of material that goes in. So the same mass of material could have a hugely different amount of manufacturing process carbon because there's more kind of a thicker section that takes longer to cool or really long and thin, different size machine as a result. So there's a really complex kind of set of levers to work on, and we do give that level of granularity. Then when it comes to regional CO2 emissions, it's often from the power grid, and there's a huge range from different countries as to where that electricity is generated. So whether it's hydroelectric, nuclear, coal, natural gas, we heard that a lot in Peter's keynote this morning. That's going to really make a big difference to your manufacturing process carbon. So because FuelCell are kind of just starting along the road, I decided I would take one of their examples and test both myself and aPriori, worked with Ben on what would be a good example to use, and look at how you can leverage aPriori to make decisions around cost and carbon. So we took one of the components and ran it through a bunch of different iterations and then looked at different sourcing decisions as well. So we needed a baseline to start with. Can you just explain what this assembly does, just briefly?
Yeah, sure. So this is the inner base for our fuel cell module. This is what we would build our fuel cell stack on. So it needs to hold the weight of the stack as well as provide some anchor points for some compression systems and things like that.
And it's in quite a corrosive environment?
Yeah, so it's hot and wet, so it's fairly corrosive, yeah.
Okay, excellent. So in the workshop, this was analysed. So we've got our cost for assembly and all the components at around $2,000, and the CO2 was around 1,500 kilograms or 1.5 tons. So we had our baseline to start from. So bear in mind, I'm just the marketing guy, so don't laugh at my CAD models too much. So took the same material. I thought, well, let's see if we can consolidate it as a single part. That's going to remove the assembly operation. Let's just try it. So I quickly knocked up a part that could be machined. We kept the annual volume the same, kept the location the same, and my cost went through the roof. So it wasn't a very good start as a good representation for marketing. And the carbon also went up a lot. So that wasn't so good. So I thought, well, maybe it's the material. So I tried a different material, went for a different steel, but powder coated it because of that corrosive environment. Stuck with machining, same volume, same location, still a slight reduction in cost from my previous iteration, but still a lot higher than Ben's original design. So didn't look like I could do much to improve upon that. So kind of went back to the drawing board a little bit and decided to go for a cast design. So you can see I've updated the design. So there's a bit less material. So you can see I've actually thought about the DFM a little bit, removed some of the material, and straight away we've got a cost improvement over the original, and also a fairly significant saving on carbon as well. So I was quite happy with that design. I thought I'd leave it there. Didn't want to do too much further to it. So I thought next thing to do is leverage the supply chain that FuelCell's got and look at different locations around the world to see if we can further reduce it. So I took the USA, Mexico, China, and India, and ran it through aPriori, and got some cost results for the part and some different carbon figures. So you can see quite a big variation in those four. But just to summarise what I ran through, so six different iterations after the original design, and you can see by choosing different locations, there's a huge variation. So it's just not intuitive. You do need to kind of run through and figure out where the costs are and where the carbon is. So, but they're all data points, and you can make decisions from these. So whatever's most important to you and the business, you can use these data points to drive decisions, which is really the key. So in summary, it really enables innovation because you can just try things out, and there's no one's going to laugh at the results. It just gives you an idea of what's going to be the right direction. So you can really fill the funnel for strategic opportunities, and it just gives you really clear insights on what's good, what's bad, from quite a high level, and look at whole assemblies and where to focus using the analytics. So when it comes to reducing cost and carbon, that's what we expect. You can determine lower costs, reduce the environmental impact, and reducing the environmental impact is going to increase the value of the product. More consumers are going to want to choose it, more customers are going to want to choose it. You're going to maintain a higher status with who you're supplying to. And it gives you that extra agility by being able to validate different options, try what if we do this, just means you're going to make better decisions earlier and stay competitive. So really the crux of it in my mind is it's data-driven decision making, and that's what we all want to do. We want to remove the emotion, the intuition from it, and make decisions on data. So I want to say a big thank you to Ben and to FuelCell Energy for coming and sharing their story, and thank you all for attending this session.